Hello, I'm going to be making an instructional video on torsion. Here are the topics I'm going to be covering: what is torsion, torsional stress and strain, the torsion formula, and angle of twist. So what is torsion? Torsion is the twisting that is going to be caused by a torque about the longitudinal axis of an object. An example of this is this shaft, which is going to be creating torsion around this screw when it's being tightened. What causes torsion is a torque, so the torque is going to be formed in the wrench and is going to cause the torsion in the screw. Next, I'm talking about stress and strain. So strain measures angular deformation caused by torsion. Strain is dimensionless, and it measures the ratio of angular deformation to the total length of the object that is undergoing torsion, and the maximum shear strain is going to occur at the outside edge of the object. So here's the equation. It's going to be this shear strain is going to be the radial distance multiplied by the derivative of the angle of twist over the length of the object, which is x. So it's the ratio, and if you already have this is a simpler equation right here. If you already have the maximum shear stress, you can just solve for c, which is the radial distance right here, and p is just going to be whatever, at any radial distance you can solve for the shear strain. So while strain measures angular deformation, stress is going to measure the internal resistance of an object to torsion, and it is given in units, which are pascals. The maximum shear stress is also going to be at the outside edge of an object, as seen here. So there's also a relationship between shear stress and strain given by this formula right here. So strain is going to be equal to the shear modulus multiplied by the strain. And you can see they are proportional to each other due to the Hooke's law of elasticity. And stress and strain are basically the core of torsion, and it's very important to know them so you can solve problems. And in real life, there are a lot of things such as concrete beams and gears and airplanes that involve stress and strain. So the torsion formulas. So I didn't give the formula for shear stress. Here it is for a circular load. For a circular shaft, it's going to be this. It's going to be the torque multiplied by the radial distance divided by this, which is the polar moment of inertia. So the polar moment of inertia is the measure of an object's resistance to torsion given in millimeters or meters to the power 4. So here it is, the formula for a circular shaft. Different shapes are going to have different formulas for the polar moment, but here it is for a circular shaft. It might be a tube where it might be the outer minus the inner cubed instead, but here it is, and that's that. So next up we've got the angle of twist. So I mentioned the angle of twist before when I was talking about shear strain, and here's what it is. So the angle of twist is just the angular deformation that is caused by torsion, except instead of before where it was relative to the length, now it's just going to be the actual angle measured in radians. So the formula is going to be torque multiplied by length of the object divided by the polar moment of inertia and the shear modulus. This formula is for when the torque is constant throughout the cross sections in a circular shaft. So when a shaft has multiple torques or shear modulus of different materials or different diameters, you can find the angle of twist of the whole thing just by finding a sum of each, by summing each angular twist up to do that. And so here's a picture of an example of sort of a failure of angular twist and torsion. So a drive shaft is here, and a drive shaft is in all cars, and it converts the torque from an engine into power in the wheels that can get a car to start moving. The drive shaft here is broken, and it seems that while drive shafts are usually elastic and go back to its original shape, the torque applied here may have been too large, and the angle of twist may have reached its limit, and it may have caused permanent plastic deformation rather than elastic. You can see by the way it broke that it is a torsional load failure. So it's a car, and cars are important and relevant, and you can see how it's important to understand to prevent this from happening, since we're going to be engineers and designing cars and stuff. So here's the end. Hopefully by now you can solve a lot of problems using torsion with all the formulas and stuff. Here are my sources. Alright, that's it.